Okay, so what we're trying to do here is use a efficiency rating model from a game that a lot of Americans can relate to, and it's a little simpler and easier to understand in terms of applied analytics and what efficiency means, and that's football, right, or American football. And people are familiar, at least have some familiarity with, the modeling of a football game according to QB rating or NFL passer rating efficiency, right? So what we're basically trying to create here is a NFL passer rating efficiency type model for soccer players, okay? And what we're doing is analogizing and then using statistical regressions from past results to figure out how good the model is or what the analogy means, and how it can give insights into individual soccer players and teams in terms of their efficiency, right? And efficiency is everything. Net goals, right, is basically what you're trying to get at with efficiency. Now, there aren't enough net goals in soccer to measure that and have it be meaningful. There's a lot of luck in the game. So what we're trying to do is measure what we believe are key performance indicators. We call them here, let's call them attempts under the QB rating model, but any decision, whether it's defensive or offensive, that's successful or should or attempted, right, leads to the number of attempts that you have, right? And then completions is what percentage of those decisions were properly executed, whether it's offensive or defensive again, right? And then yards would be packing. So in the NFL QB passer rating context, right, it's very clear what the efficiency is. The ball's moving down the field. The more the ball moves down the field, the greater chances of a touchdown. It's the sum of a parts game. The greater the QB efficiency, the greater the scoring over time. Chances are the greater you're going to win the game, all right? The greater chance you're going to win the game, right? Not quite in soccer, right? But if we're progressing with that model, then what we want to do is create a completion value to every one of these decisions. These one successfully completed decisions, right? We want to have a completion value. And for instance, the packing statistic is a great one. You give 10 points for bypassing one player, 20 points for bypassing two players, 30 points for bypassing three players, and so on. You give 10 points for ball recoveries or winning a 50-50 ball, that kind of thing. And that's a very common approach in soccer, the packing statistic, right? But this rating model, this efficiency model, will relate that efficiency or those efficiencies to actual scoring and the impact that those key performance indicators have over time, which is what we're trying to get at, right? Now, if we just measure net goals over time, it's not significant because too many factors change. But when we talk about efficiency over time, you can get a much stronger data set over a much more relevant constrained time window, maybe even down to a game or two. And so what we're looking at is modeling player efficiency along the lines of basically the NFL passer rating, right? So here's the model in a nutshell. We're going to look at every decision on the field. We're going to call that an attempt, right? And then from there, we're going to proceed to find out what decisions, and those decisions are agnostic. They're basically what your game model calls for. So I coached a game last night. Most players had 40 decisions, 50 decisions, somewhere in there. And for the most part, they're completing 67 to 70% of their decisions, according to the game model, right? We don't want people doing things that are not relevant to the game model. And then, so there's a baseline value of every completed decision has 10 yards, let's say, or a packing value of 10, right? And we're going to subtract the fact that probably each player was involved in one shot or one good chance conceded. So historically, that's been a deduction of 80 points. But also about 10% of the time, the players are involved in high packing events and about once out of that 40 or 50 decisions, the players are involved in the creation of a good chance. So most of that's a wash. We'll call it a packing event at 250. One goal chain, right? They're part of a goal action, and at least once for every player, a decision led to a shot conceded. So what does that mean? So if you were the NFL quarterback as a player in that game, what would that mean? Right? So we put all that information into the rating calculator, right? And then we're going to run a statistical regression on a weakest link game model, not a sum of the parts game model. But this is a 0.78 or 0.78 player efficiency rating. The player thinks they're doing great, right? The player really has a good sense that they're doing fine. Problem is, if everyone has a 0.78, right, where does that leave us? So we're going to do a weakest link, not a sum of the parts. So if you're the sum of parts game, you think 0.78, my contributions added to the other player's contribution, and the team is getting better because I'm doing 70% of my stuff right? Unfortunately, soccer is a weakest link game. So you have to multiply your rating 10 times if everyone has roughly the same average rating. And that results in a team efficiency rating of 0.08. Now, we still don't know what that means, right? We have to go look at historically what the net goal result was of a 0.08 team efficiency. And so we've done that work across dozens, if not hundreds of games. But here's a very quick statistical regression game model at the semi-pro level, which was the semi-pro level I was coaching last night, and I had a good sense of what the overall player profile was, and I've input the average overall player profile was, and I inputted here, right? I honestly think that evaluation of a player profile was generous, right? But long story short, team efficiency 0.08. You're in total failure. You're almost guaranteeing yourself to lose at a 0.6 team efficiency. Now,